It is a pleasure to be here. It is amazing to see so many people over here. It is absolutely great. I cannot believe that a little idea that we had a few years ago has grown to such a wonderful and enormous size. So thank you all for being here. I really appreciate all the support we have been getting. We want to talk about Angular. Specifically, I want to talk about how we are not building a language. Just to make this clear, we are not building a language. And the thing we're not doing, that's called AtScript. And so why are we not building a language? Because, there's a lot of people who say, if we only had a better language, we could build a better set of applications. And we have a slightly different vision of how we could build better applications, and we'd like to share it with you. So first of all, let me tell you that we absolutely love you, and we would never force a language upon you, and we're very sorry about the APIs in Angular that we have. If I ever meet my former self, I will have a chat with myself about how we got here. So let me show you what I mean by our APIs. This is how you declare a directive, right? So in this case, we're bringing back the time, and we're going to make the blink directive that was taken out of HTML because I really miss it, and we're going to bring it back over here. And this is kind of how you do it. It's a lot of things, and they all kind of have some meaning to it. But let's talk about a couple of them specifically. First of all, notice the highlighted yellow bars. They're underscored because it's actually an argument we don't care about in this particular thing. The first argument happens to be scope, for those of you who are following. The element is something we're going to need. The third argument is attributes. Those we're not going to need in this case. And finally, we have options. Now, what's interesting about it is the options is actually, the first three arguments are positional. They're fixed. The last argument is not fixed. It's actually injected from the require up here controls the options down here. And it's a form of dependency injection, but we also have dependency injection up there. So that timeout controls the timeout in there, right? And just for good measure, this restrict thing controls the thing up top, which is the blink that it is limited to attributes. This is not very intuitive, is it? And as I said, we're very sorry about this, and we'll talk about how to fix this particular thing. Why two different kinds of dependency injections? Well, it turns out that the one on top injects global things, and it's always the same thing you're going to get injected. The one on the bottom is actually specific to the location where you happen to be inside of the DOM. This is why we actually had to have two different injection systems. But can we do better is really the question. Can we somehow take this convoluted API and turn it into something nice and friendly? Before we get there, though, let's talk about what is inside of the function. So here, this is made up. This is not meant to really make much sense. But suppose you call some third-party API, and you get back something you call selectors. The trouble is, you don't actually know what selectors are. Now, you can kind of look around, and you can see, like, oh, we're going to do selectors that join. Probably it's an array of some sort. And because we're going to say element.query, we can say, I see. We're actually going to be joining what looks like a bunch of CSS selectors. The trouble is it's all implicit. It's all something that you have deduced by looking at the code. It is not something that is explicitly written anywhere. Finally, we're using ES6 over here. That's the fat arrow syntax. The options that apply, it is not clear what apply takes. Again, we can deduce that it's probably going to be element. But the trouble with this deduction thing is that in a simple example like this, we can actually deduce things. But imagine you have hundreds and thousands of lines of code. It becomes really tedious and difficult to figure out what all these things are. And there are limits to the introspection or the induction capabilities of the language that can actually figure these things out. So it'd be much nicer if we could actually somehow annotate and say, by the way, the selectors thing, if the person who comes after me, who's going to be reading this code after me, I'm going to leave you a hint for you. This is actually going to be an array of CSS selectors. And finally, it'd be nice if I could actually help the IDE and tell it that this is going to be an element so that it can verify that all the pieces work together properly. What we want is something like this, where we can say selectors colon array CSS selectors equals some third API. Now, it turns out, and we're going to talk about this later, is that this syntax is not new. This is something called that ecmascript 4 declared, and it is something that most people agree is the syntax of what the post-ES6 syntax for types is probably going to be. It is also the syntax that TypeScript uses. So if we had this kind of syntax, we could really explain to the people after us what exactly it is. And the other thing I want you to point out to is the thing on top. It says @directive. This is a metadata annotation that basically allows us to declare what this particular thing, what its intent is, how it should be used in a system. And so in this case, something like Angular could look into it and say, I see. What you're trying to do is you're trying to declare a directive. And you're giving me a CSS selector. And there's a string up there that actually specifies what the selector is. And notice that instead of having a function inside of a function that returns a function, you actually have just a first-class citizen called a class, right? And the class says this is going to be the blink. It's going to be a directive because it's annotated above. Notice that the constructor says, these are the things I need. I need an element, options, and timeout. The type information is directly inlined. Notice we don't have to ask for things that we know we don't need, like previously there was a combination of positional and injected attributes. Everything is in a single location, and everything is nicely packaged. This is what I think would be a wonderful API for you guys to build the next generation of amazing apps. And this is the API we would like to deliver for you. But in order to do that, notice there are a whole bunch of constructs that are currently not available in JavaScript, namely the annotation above and the type annotation on the right-hand side after the colon of the parameters. So how can we do this? How can we get there? So first of all, as I said, we're very sorry about this API, and we're going to make it right. And here's our plan how we can make this right. But first, let me explain why not build a language. Like, it's very tempting to say, let's just make a brand new language and fix all the mistakes that we have seen other languages to do. The trouble is that chances are you're going to make a whole new set of mistakes that you're not aware of. And it's not just a set of mistakes that's problematic, is that there is a huge amount of investment in the existing language and infrastructure, everything from tools to libraries to people's knowledge. And when people create new languages, you want to be able to preserve all this stuff and be able to leverage it and take it to the next step. So really the thing is not to build a new language, but to really extend the current language that we have, which is the JavaScript. And so that reminds me of my favorite cartoon, which is XKCD. Who's a fan of XKCD over here? Yay! All right, you get my kind of people. So the situation is we have 14 competing languages. 14? That's ridiculous. We need to have one language that covers them all in every single use case. So soon we have a new situation. We have 15 competing languages, right? So let's talk about the ideal development environment. What is it that you guys would love to have in order to build amazing applications? First of all, if you have large-scale teams, I'm talking about teams where you have 5 or more people on. We have teams that are building software at Google where we have 50 people working on a particular project. Once you have a team like that and you have lots and lots of code, tens of thousands of lines of code, hundreds of thousands of lines of code, types become very important. And the reason for that is there is no one person who understands how the application, how all the types come together in the application. Instead, people leave contracts for others when they come behind, right? So I'm going to say, oh yeah, these are the types that I expect over here, and I'm going to leave this in the form of annotations so that when somebody else comes and looks at the code, they don't have to understand the whole system. It is sufficient to look at the contracts, these types, and say, oh, I see. I'm simply going to trust this type annotation over here, and I'm going to assume that the type annotation is correct. And so what types allow is they allow for large teams to work together. But there's another important part of this, which is that it has to be optional. And the reason why it has to be optional is because we have all of these existing libraries inside of JavaScript world that are untyped. And therefore, we cannot expect that all these libraries will upgrade themselves to type system. And so it's not only that we cannot expect, but it actually turns out that there are good arguments that type systems are not free. Type systems have their benefits, but they also have their costs. And so you should do the type systems only when the benefits outweigh the costs. And so there are plenty of reasons or plenty of use cases when I actually don't think that the cost of adding the additional types is really paying the bills. And so the key over here is they have to be optional. Now the trouble with optional type system is that we need a way of asserting things. And if you only have the half of your source code typed, it becomes very difficult for something like static analyzer to figure out if the system is correct or not. And so we're going to talk about how we're going to address this later. The next thing you need is metadata. And what metadata allows you to do is to express your intent. Instead of giving me individual instructions on how to center something, you can just say, I want to center this. And intent is a very important thing because it allows to build abstractions. It allows you to build large systems and to communicate in a very succinct way your intentions to the other developers on your team. And finally, the important part is that these things are great, but if you want the frameworks to take advantage of them, the frameworks need to be able to look at these types at runtime. So we need some form of introspection. And this is the kind of the sweet spot of AtScript. These are the properties that we would like to see a language have so that we can enable you guys to build the next generation of wonderful applications. So let's talk about the types or the contracts, first of all. So let's say that you have a public API add class. And as I said earlier, you can kind of look at this and figure out that the selectors is probably going to be the array of CSS selectors, and the name is going to be a string. But unfortunately, these methods are usually humongous. They're not one-liners. And usually, you don't even get to see the source code. You just are working in your IDE. You suppose this is jQuery. And so it'd be really nice if we somehow could hint to the IDE that these are an array of CSS selectors, and the second one is string. This hint is what basically would allow IDEs to add wonderful things that people in the Java world are used to, such as refactorings, renaming, and so on, code navigation, and so forth. I mean, it's amazing to me what IDEs today are able to do without any sort of type annotations. Imagine what they could do with type annotations. So now, let's look at it further. Now, it's not sufficient to say that something is an array. You actually want to have generics and say this is an array of CSS selectors. Now, what is a CSS selector? This is kind of where JavaScript is unique because it's structurally typed. CSS selectors basically says you're a string that follows a certain regex. You know, something like that can actually not be expressed in a static type system. You cannot verify that you have an array of something that are strings that follow a certain format, which can be verified by a particular regex. And so this is typical of JavaScript, right? That you are passing strings that are CSS selectors and so on. And so when you have structural types, it is not that you are something. It's that you have a particular structure that matters. And this is something that we would like to enable in AtScript. The way we can enable and we can enforce this is that when you write these annotations and when we can compile them in a development mode, and the key over here is the development mode, we can insert assert statements that actually prove or verify the contracts that you said about the code. So when we put information about this selector is an array of CSS selectors, we can actually, at runtime, verify that you are actually getting what you think you're getting. And this is important because when you're talking to a third-party library, such as a jQuery, and jQuery returns something to you, you think that there is a contract between you and jQuery. And so you can easily say, I think what you're returning to me is going to be a string. And by putting that in your code, you're, in essence, putting an assert statement in your code that says, if jQuery returns something other than string, that means my assumptions about jQuery are wrong, and I want to know about it. Now, obviously, verifying these things at runtime does have a particular performance impact, and so this is only for development mode. Once you are sure that your application works correctly, and you transpile again, you actually remove these assertions from your production code, and there's zero performance penalty for you. Now, this is something that this trick is something we have learned from actually Dart when we were building Angular Dart. And it works surprisingly well. This is actually how Dart does its type system by verifying many things at runtime. They also have a compile time verification, but the runtime verification is the kind of the complement of the two. And it works, as I said, surprisingly well. And so we would like to bring this wonderful benefit to JavaScript as well. Now, notice how the type systems have been expressed in the form of asserts. And so you need a runtime type system assert framework. We are going to ship one with AtScript. We're going to call this, we're just calling it RTTS for now. And it can assert nominal type system. That is, you are something because you directly inherit from something. This is a typical Java inheritance model where you are a car because you inherit from vehicle, right? You also have structural type system, which is you don't have to inherit from anything, provided that you have a set of properties that I expect. You are that type. So this is an example of CSS selector where we said, you're a string and you happen to pass this regex, then I'm going to consider you a CSS selector. And you need to be able to put these two things together in the form of a generic. So you can say things like array of CSS selectors, or map of things, or promise of something are a way to put it together. Now, the reason why we did this as a library is because when you get to the business of talking about types, the semantics of types is a wonderfully complicated discussion that you can have for years on end and never come to any particular conclusion. And we wanted to make sure that we can express things in the syntax, and we can all agree on the syntax, and we can then debate the semantics of it over time and can easily upgrade our semantics just as we can upgrade libraries inside of our code. So by putting all of the semantics in a runtime library, we're kind of sidestepping this huge hurdle of agreeing on what exactly the semantics of the type systems are. Now, there's one more benefit you get out of being able to check types at runtime, which is that usually when you're building an application, you're talking to a server, and a server is giving you back JSON. And JSON is structured data that doesn't actually have types. It's just hashes, right? And so with runtime type system that's structural, you can actually verify that the server is actually giving you the things that you expect. You can think of a server as an untyped source of data, and then you are placing contracts inside of your application that can actually verify that the server is giving you what you want. And this is something unique that you can only do at a runtime type system. You know, a lot of people are trying to solve this particular thing by having types that they compile both in the client and also on a server. I think this particular thing can be better solved by having an assertion that you say what your expectation of the server are, and then you can verify it in a development mode. And as I said, you turn this off in production once you're sure that everything works. Now let's talk about one more important part, which is the declarative metadata. Like, type systems are great, and we've seen many benefits, and they enable things like dependency injection. But really, the declarative thing is what we're looking for. If you're thinking about what the module.directive is, it is a form of a declarative description where you declaratively say what you require, what you restrict, what your timeouts are. But it is kind of confusing because you have this thing that takes a function that can be annotated by an array of things in front of it, which returns an object which has a link function, which, you know, it's just convoluted, right? Can we do better? And so the thing that we can do better is we can take advantage of things that have been known for a long time, like, hey, can we have a class? Can we nicely encapsulate the directive as a class where it can have its own private methods and all the stuff that goes with the class? And can we add an annotation, which is what the intent of the class is? So here, the annotation can succinctly express the intent. There's no need for require. There's no need for restrict and all the other secondary things like link and so on. Simply by declaring a class and saying that we have a constructor, and these are the parameters we have. Notice we can mix things. We can say element, which is going to be different for each instance, but also have something global like timeout. And because we can place types directly inline, the whole, putting it inside of an array with extra string parameters in front of it simplifies things as well. Also notice there's actually no strings passed over here. So this code is completely safe for minification, and it won't break the dependency injection system. Yeah. I'm glad you like that. So, but what is a directive? If you look at it, directive is just another class which declares, what the string happens to be, what its constructor happens to be, how it saves it, and so forth. And if you're placing @directive at the bottom of it, you really are just saying new directive. You're just instantiating one of these things and somehow attaching it to the class called Blink. Now, how do we get a hold of this thing at runtime is the key part of it, which is the introspection. So imagine we have something very simple as we have a class called door, which takes a lock, and it's annotated with the material called wood. So suppose there's another class called lock, as you can see over there, and we also declare another class called material, which takes the type and it stores it over here. Here are the properties we need in order to be able to do introspection at runtime. The first thing is we need to be able to pass types around as first-class objects. And JavaScript is really good at it. So in JavaScript, you can actually say door equals type. And this may seem like obvious to you because you've been in JavaScript for so long. But it turns out many languages cannot do this. So for example, a statement like this in Java is not possible because door is something else. It is not something I can assign to a variable. You can say door.class, but then what you get back is an object representing the type, not the type itself. And the way you can know that it's not the type itself is because you cannot put a new operator in front of the type itself. Whereas in JavaScript, you can easily put a new operator inside of the in front of the type, and it actually works. This property that code and data is one of the same thing is not, I wouldn't say it's unique to JavaScript, but it's one of the wonderful things that JavaScript enables. So by being able to pass types around in the system, we enable metaprogramming. But the next thing we need to do is we need to get a hold of the material for this particular door. How do we do this? We can do it by simply saying type.annotations, and we can say, give me the first annotation, because you can have as many as you want. Notice all we're doing is we're monkey patching a property annotation on top of the type constructor function, which is represented by the class door. And we're going to do this automatically for you, but it opens up the possibility that if you choose not to use AtScript, and it's a very important goal that you don't have to use it, and we'll talk about more of that in later, all you need to do is monkey patch the annotations property on the constructor function, and just you put an array which instantiates the new material with wood parameter on it. And in this way, we can say we can expect that the material type would give us wood. And this is what frameworks can use to introspect on the code you have declaratively written. Similarly, we should be able to get a hold of the parameters and say, give me the type's parameters, and get back the array of it, which is the array of lock. Notice, in this case, no strings present. This is actually a reference to a type constructor function lock. And if the minification system you happen to be using renames lock to a variable a, because that's shorter, it will also rename it over here, and it will work as expected. So one of the things we would like to enable is for you guys to be able to have expressive code. And what expressive code needs is type annotation and introspection. And these are the pieces that we would like to add to the language that you currently know as JavaScript. So how do we get there? How do we add all these particular pieces? First, I would like to talk about how we build applications. And I think the key point over there is abstraction. And why is abstraction important? Well, I think there's a lot of people who are running around and say, you know, if we only had a better language, building web applications would be easier. But I think that's only part of the story. And this is the kind of the real elephant in the room, which is that the reason why apps are difficult to build is because the abstractions are not right. If you look at the browser, JavaScript might have its faults, but at the end of the day, it's good enough to talk to the API of the browser. But the API of the browser is the thing that really gives us headaches, right? It's the thing that is problematic here. Can we fix abstractions? And if you think about what a framework like Angular is, it is really increasing the abstraction level of what a browser is. We give you new concepts like directives and controllers and data binding. And through these abstractions, it becomes easier to build applications. So it is not that languages are not important. It's just it's not enough to have a better language. What we really need is better abstractions. And we get better abstractions by allowing developers to be expressive. And the expressiveness here is really declarative about the intent. By allowing you to simply say, I want X, rather than implementing what the X is through a series of operations, for loops, and so on, by being able to simply say, I want X, is a great way of heightening the kind of abstraction you can have for building applications. So abstractions through declarative annotations and contracts are two different ways by which these abstractions can be made more declarative. And the declarative thing is really important because you all know how wonderful declarative things in HTML is, by being able to say things like ng-repeat and all the magical things that happen just by saying something like ng-repeat. Can we do the same thing for imperative JavaScript? So first of all, these are not new ideas. These ideas have been tried and verified, and we kind of know these things from other languages that they are kind of wonderful. But let's see how we got here. I mean, to me, the whole thing starts with ecmascript 3 in about 99 when we added try and catch to the language. And try and catch seems like a benign, simple thing, but it's really the thing that kind of enables you to build large-scale applications, right? So all of a sudden, we have fully fledged language from which we can start building applications. And first apps like Gmail kind of really proved the viability of this particular approach. And so people get excited. And in 2007, ecmascript 4 came out, and it had types, classes, and modules. Like, these are high-level concepts that we still don't have today. Unfortunately, through a lot of different reasons, people could not agree on what the best way forward is. And ecmascript 4 kind of ended up into this thing called an ActionScript that was available using Adobe Flash Player and Flex Framework, but it never actually made it to the mainstream. So when ecmascript 5 came out, it was actually based on ecmascript 3, not on ecmascript 4. ecmascript 4 kind of became the dead end. And in 2009, we got strict mode, which was a ecmascript's way of trying to take away some of the sharp edges of JavaScript. And strict mode is a wonderful example of how what we're doing here is we're not implementing a brand new language. We're simply making what we already have better. And now with ecmascript 6, we're adding things back like classes and modules. So it's called ecmascript 6, recently renamed to ecmascript 2015. And classes and modules and a whole bunch of other wonderful syntax got added into ecmascript 5. Browser vendors are in a race to implement this all natively. You can have all of this today through Tracer, and Eric's going to talk about that more later, about what Tracer can do. But the thing that's missing out of this is actually types, or the type verification, metadata, and introspection. But this is coming. We don't know when, whether it's in ecmascript 7 or ecmascript next or what's going to happen. But make no doubt that these are things that have been proven in other languages, and they will eventually come to JavaScript. So what we're trying to do here is we're going to say, look, these things eventually going to happen. So how about we just put them into Tracer today and allow you to take advantage of them today? Maybe we won't get the syntax right. Maybe we won't get the semantics right. But chances are pretty good that we actually will, because there's a whole bunch of prior art. Things like TypeScript and ActionScript have all kind of laid the plans of what the syntax of these things should be. Java have laid the plans of what the syntax for metadata annotation should be. So with a reasonable confidence, we can actually say, we think that the future is going to look like this. And instead of waiting for the future to arrive, we can just build the future today and let you use it. And this is the kind of the idea behind AtScript. So you take ecmascript 5. This is what you're using today. This is really JavaScript that you know and love today. And we know ecmascript 6 is coming, and it's bringing classes and modules with it. And the important point here is that ecmascript 5 is a valid ecmascript 6 program. So you can take all of your existing libraries and code and everything that you love about your current stuff and that you're familiar with, and you can just put it in the ecmascript 6, and it all works. And this is an important property. This is what makes ecmascript not a new language, but really just an extension. On top of that, you have languages like TypeScript that are extending the types. Now, this is not quite correct today, because today TypeScript is a superset of ES5, not of ES6. But we know that Microsoft is hard at work to make sure it will be a superset of ES6. So while this might not be correct today, soon it will be correct. So things like TypeScript are already taking this idea of like, let's take what we know is already a standard, which is ES6, and let's extend it with what will probably be a standard tomorrow. And let's pave the path of how we're going to get there. So we're just going to take this, and we're going to take a step further and say, OK, this is all wonderful. Types are all great. But we also need type annotations and introspection. So let's add those on top of that. So really, AtScript, the point here is that TypeScript is a valid AtScript program, and ES6 is a valid TypeScript program, and ES5 is a valid ES6 program. Now, as I said, we're not quite there yet. TypeScript has a little work to do. We have a little work to do. But this is the vision. This is where we want to get to. So you have a nice set of extended capabilities of what you already have. So now let's look at one more important point, which is that we don't want to force you to use a new language if you don't want to. We think this language has a lot of benefits, but there's a lot of reasons to stay with ecmascript 5 as it is today. And so all these wonderful new features we're talking about that should enable Angular to be able to be even more useful and allow you to have a better syntax should be something that you should be able to do today in ECMAScript 5. How do we get there? Well, the way you would declare a class or something that represents a class in ECMAScript 5 today is you create a constructor function. You should be all familiar with this, right? You say function blink takes element options and types. Now, how do we get annotations on top of it? Well, we can just say blink.annotations. We're essentially creating a static method, static property onto the blink class and saying this static property has an array of annotations. In this case, it's just instantiate a new class called directive, and I'm going to pass in an array of selector, which happens to be a blink. You can do this today. Similarly, with parameters for the dependency injection, you can do the same exact thing. You can pass in other types that already exist in the system that together allow you to describe what the annotation would have been at AtScript. And this is an important piece that we have spent time to make sure that you can express yourself in ECMAScript 5 today. Now, it's not as nice as TypeScript, mainly because the constructor functions tend to be very large, and so the annotation and parameters, they will be too far down from the element options and timeout. And so it makes it kind of difficult to verify that you have the right order in a constructor with the order of parameters down here, but it's certainly a workable solution that you can do today. ECMAScript 6 comes along. What can we do better? Well, we can upgrade our constructor function to an actual class. We can now say we have a class blink, constructor options and timeout, and we can continue to have the same set of annotations. Let's say you decide to use something like TypeScript. Well, what we can do is we can now take this annotation and move them closer to where the constructor is, and we can actually move them ahead of the constructor so that you can verify the parameters, element options, and types are very close to the constructor and they actually match the names. You still kind of have to repeat yourself twice, but it is kind of a better syntax already. And finally, if you come to something like AtScript, you can actually express yourself completely inline in this particular way. But all of these things that we have shown you are isomorphic. They're all the same way of expressing the same exact thing. If you would like to use CoffeeScript, you could do this thing today as well. So it's important for us that whatever benefits that we introduce in AtScript, you can actually, and if Angular is going to be written in AtScript itself, you should be able to use Angular without you yourself having to use AtScript. So let's talk about a roadmap. This is where we are today. Angular 2 is being built, and is being built on top of AtScript. What we can do today is we can consume a .ats file. We have the AtScript running on top of Tracer, and we can spit out a ECMAScript 5 file and also a Dart file. So we're also using this as a transpiling platform for both, so that we can generate both AngularJS and Angular Dart from the same source code. This is how we're going to make sure that we have a unified source code. There's going to be only one Angular, and that the team itself doesn't have to worry about two sets of bugs and so on. Now let's talk about a roadmap where we would like to get. As I said, we already have an implementation of AtScript that can produce .js and .dart, and we have runtime type checking that we have described earlier today. What we'd like to do is add IDE support. We have talked to many of the vendors of most popular IDEs. We have expressed our interest over here, and they were very enthusiastic about adding support to these things. Most IDE vendors already support TypeScript, so they already have the full syntax of everything that we have described. Adding the annotations is a relatively small step for most IDEs, and so we think we can get this hopefully soon. Next thing is being able to actually run static type checking. Something like TypeScript already has this today. We think we can have even a better story because we can have partial optional type system. We can verify some things statically, and some things we can verify at runtime through the runtime type checking, as we have said earlier. We would like to align all this stuff with TypeScript. And we're already, we think once we have all this thing and we have we have actual real world applications using it, and we have a lot of knowledge about what works and what doesn't work, we can go to the ECMAScript standard and produce a proposal. And because we're already aligned with TypeScript, it should be much simpler to propose something because you have two existing systems that are already using and they're already aligned. We can take this to browser support, and we know that Chrome is interested in having some form of type system, and we think that other browsers are thinking the same exact thing. And then hopefully we'd like to take this to ECMA standards as whatever the next version of ecmascript that we might have. So the kind of the summary is that AtScript, it's a name, but it's not a new language. It is really ECMAScript 6 plus types plus annotations plus introspections. And this is together, we think would enable you guys to build even better applications. And you can already see some of this stuff today on the Angular repo. Thank you very much.